Hi everybody, in this video we're going through the vector work that we did last year. Now you've seen all of this stuff before, but a lot of it you haven't looked at since September, so it might be a bit rusty. Okay, first up, you'll remember that we can use these brackets here to represent a vector. This here means that it's 3 steps to the right, and the -2 here means that it's down 2. So a directed vector representing 3, 2 would be something like that. And remember, we put an arrow on the end. Now that vector like that, remember that it can move anywhere. It can be in any of those positions as long as it's 3 to the right and down 2. Okay, next example. The vector u is defined by the directed line segment from this point here to this point here. Now notice here we've got u in bold. That's often how you see a vector written when it's typed, but if we were writing it by hand, we'd put the little squiggle underneath like that. Okay, if u is equal to a, b, find a and b. Okay, well if it's going from point x to point y, how do we find out what that is? So vector xy, we would say, is going to equal, well, the horizontal movement is going to be 3 take away 2, and the vertical is going to be 1 take away 6. So it's going to be 3 minus 2 is 1, 1 minus 6 is -5. So a and b, 1, -5, just like that. So just think about it. If we've got 2 points, and our first point is 2, 6, 2 across 6 up, that can be there. Next point, 3 across 1 up, and we're going from this one, from x to y. Let's see if that works. We're going 1 across, that's this one here, 1 across, and we're going down 5 steps. That's right. So 1 across, 5 down. So what did we say here? We said this one minus that one, that's in the horizontal direction, then this one minus this one in the vertical direction. Okay, next we're given vectors u and v, and we're asked to find 2u plus 3v. Now let's first remember these little numbers here. They are scalars, aren't they? They're not vectors. That means 2 lots of vector u plus 3 lots of vector v. So it's 2 lots of vector u plus 3 lots of vector v, and we can just multiply those scalars through. And then we just add up the horizontal components. 6 plus minus 6 is going to be 0. -2 plus 6 is 4. So that's the answer there. Okay, this question's a little bit more complex. It says let's think about this triangle we've got over here. And a to b, that's this vector here, we're going to call little a, and we're going to call b to c, all of that distance there, little b. So find each of the following in terms of a and b. B to d, well this here, d we're told is the midpoint of b and c. So what can we say? We can say this little bit here is going to be half of vector b, isn't it? So it's going to be half of b, and this one here is going to be half of b. So what is b to d going to be? B to d is going to be half of b, or vector b on 2, about d to c. D to c, again, is going to be half of vector b. A to c, well we're after a to c in terms of vector a and vector b. So to get from here to here, how am I going? I'm going vector a plus vector b. Next, a to d, how am I going to get from there to there? It's going to be a plus vector b on 2. And final one, c to a. So if I'm going here to here, well I'm going to have to go backwards along b, aren't I? So it's going to be -b, and then backwards on a, -b minus a. Okay, this next example I've put in to remind you what the unit vectors I and j are. Now this guy here, I, he has a little cap on his head to show you that he is a unit vector. That means his length is 1. Okay, so a unit vector 1, and it's I in the I direction, that's horizontal. So that is like that. And j is in the vertical direction, 1 unit up. Again, they're unit vectors, and that's why they've got their caps on their head. Again, textbooks often don't put that in, they put them bold instead. Okay, so we have 0 to a. This vector here is 3i. So that's O to a is 3i, and O to b is 2i minus j. So this one is going to be our second vector there, OB. Now we're asked to find a to b. Well, if I want to go from a to b, how am I going to get there? I'm going to have to go backwards. So this one here is OA. I'm going to have to go backwards on OA, so that's going to be negative OA, and then I'm going to go forwards on OB plus OB, like that. So what is that going to be? Well, OA is 3i, negative OA is going to be negative 3i, and then plus OB, so that's going to be negative I minus j. And let's see if that's right. So that would mean 1 step to the left and 1 step down, which is exactly what we've got. Next question, find OM, where M is the midpoint of AB. So that is going to be there. Well, if vector AB is minus I minus j, what is half of that going to be? Well, it's going to be half of AB. It's going to equal minus I minus j over 2. We've got half of that. Now the question asks us to find OM. That means from the origin to point M here in the middle. So how are we going to get there? Well, we're going to have to trace it along OA first, and then we're going to have to add half of AB. So that's 3i plus negative I minus j over 2, and I'll just do my algebra to work out what that is. 5i over 2, take away j over 2. So 2.5 steps to the right, that's 5 over 2, that's right, and then half a step downwards. Next, we're asked to find the magnitude of this vector, 2i minus 3j. Now just remind you about our symbols. If I put those lines around it like that, that means the magnitude. So it means how long it is. So I've got a vector, so 2 steps to the right, 3 steps down might look something like that. I need to find how long that is. Now if that fits 2 there and that is 3 there, I can just use Pythagoras to find that length of the vector. So the magnitude is going to be the square root of this one squared plus this one squared. So 2 squared plus negative 3 squared. Now this is an issue I noticed in some of your work last year. It's not 2 squared minus 3 squared. No, we are squaring the negative there as well. So that's going to be the square root of 4 plus 9 is 13. So this length here is root 13. Remember, when we're talking about the magnitude of something, we're talking about its length, or its distance from 0. So it's not something that has direction, it's just the raw length of it. Hopefully all of these concepts are coming back from last year. Let's look at this next one. Let A and B be points on the Cartesian plane such that OA is that and OB is that. First thing I really want to do is just draw those vectors. As you can see, I've done that here. Now read the question. Find, vector AB. So let's draw that. That one is the one that starts at A and goes down to B. Now remember that vector AB is going to be, if it's just joining up 2 points, A and B, it's going to be point B minus point A. So point B, I'm going to say it's going to be 1i minus 2i. So that's going to be negative I. and then this one, negative 3j, take away j, negative 4j. So vector AB is minus I minus 4j. That means I'm going 1 to the left and 4 down. Is that what I'm doing? 1 to the left and 4 down. Yes. Next question it asks me is to find the magnitude of vector AB. Okay, remember the magnitude there. I'm just going to find how long it is, and all I use is Pythagoras for that. So it's the square root of this thing squared, negative 1 squared, plus negative 4 squared. That equals square root of 1 plus 16 equals root 17. Okay, next question. A is 3i plus 4j. Find the magnitude of A. Okay, so the magnitude of A, its length, Pythagoras, and that is the magnitude of A. And now it says, just read what it says here, and hence means using that information, find the unit vector in the direction of A. So what I'm wanting to find here is A hat. Remember, A hat is the unit direction vector in the direction of A. So if I have A here, so 3 across, 4 up, so it's going to be kind of like that. Now I'm after the same direction as that, but just a length of 1 unit. So well, I know that the length of this vector A is 5 units, so I'm basically just after a fifth of that. So all I do, A hat is going to equal 1/5 of 3i plus 4j. You could write it like that. You could write 3i plus 4j over 5, or you could write 3/5 of I plus 4/5 of j. They are all exactly the same thing, and that is the unit vector in the direction of A, that little one there. We're almost through now. We've just got 2 more things to remember how to do, and they are converting between polar and Cartesian form. Now you'll remember that polar form has so the magnitude of our vector there, and then here the angle. Okay, so you can call that, remember we can call that R, the magnitude of it and the angle. Now Cartesian form can be represented in various ways. It can be like that, or it can be AI plus BJ. Okay, and sometimes it's even written like that there. Now Cartesian form is also known as component form. So this textbook that we're doing a lot of our work out of this year is the Cambridge textbook, and it talks about component form. It's also called rectangular form because, you know, what we're doing is making a rectangle, that one and that one. Now here we've got vectors in polar form, and we're going to go to Cartesian form. Well, our vector here we've got is 30 degrees. That means that it has a length of 3 units, and the angle in here is 30 degrees. So how do I work that out? Well, I make it into a triangle, and what I'm after is this one here and this one here. So I can say that if I took the cosine of 30, that's going to equal adjacent A on hypotenuse, which is 3. So this A value here, or X value as we sometimes call it, 3 cos 30. And similarly, if I take the sine of 30, that'll give me the opposite, B over hypotenuse, which is 3. So B is going to equal 3 sine 30. Now you might remember about the trig exact values for 30, but we don't need to worry about that now. We can just plug it into our calculator. And there is our vector in Cartesian form. As you can see, this number here, this X value, is higher than the Y value, which we would expect because that one there is longer than that one there. So that's how you do it. You could just might like to remember this word, that if our vector is say xi plus yj, j, well then this x value here is going to be r cos of theta, and that y value is going to be r sine of theta. The sine is the y, cosine is the x. I might just do one more of those. Now this next one here is the angle is negative 60 degrees. That's going to come down here, and the length of that is 4 units. Now what are we going to do? I'm going to make it into a triangle. This is going to be the x and this is the y, and our angle in here is negative 60. So we can say the cosine of negative 60 is going to equal adjacent, that's x, over 4. So x equals 4 cos negative 60, and similarly y is going to equal 4 sine negative 60. Calculator now. And there's my answer there, just by plugging in those values. Now remember, if it's negative 60, we want to retain that negative if we're just typing it in. If you don't want to type in the negative, you just have a think about it. The x is going to be positive, the y is going to be negative. Now it says here that it's negative 60 degrees. It would be exactly the same if you did cosine of 300 degrees, because remember, if we come around that way, that's going to be 300 degrees. So either of those will work. Now just before we move on, I want to show you how to do this on your calculator. We'll be using our graphics calculators when we come back to school, but for now just get your old calculator, your little Casio, and if you want to do this, you can convert from polar to rectangular really easily. You go Shift, Rec. Now the Rec button is the second function of the minus sign. So Shift Rec, and then you open bracket, and you're going to type in, let's do this one here, 4 comma negative 60. Now the comma button is found if you shift and close bracket, I think it is, so it's the second function of the brackets, and that will just give you the x and y values. So just give that a go now. And you might need to scroll along a bit depending on how many decimals there are. It will tell you the x and y. Just make sure that you can do that both ways. If you're pushed for time or we're not getting assessed directly on that, you can just use your calculator, but you do need to be able to do it by hand as well. Now here in our final example, we're going back the other way. So we're going from rectangular or Cartesian form or component form, whatever you're going to call that one, back to polar. So what are we going to do? The first one, I just always like to sketch it first. We're going to go negative 4 root 3 and then 4 up. So it's going to look something like that. So it's here, negative 4 root 3 and 4 there. What I really want to know is I want to know the length of this. So how am I going to work that out? I'm going to use Pythagoras, and that will give me the magnitude of the vector. So it's going to equal the square root of negative 4 root 3 squared plus 4 squared. And that gives me 8. Now I shouldn't really need to say at this stage, but if you're just typing that in your calculator, you need to put the brackets around all of that. Otherwise, it won't include that negative in what you're squaring. So just keep that in mind, otherwise you'll make mistakes. So the magnitude here is 8. The next thing I'm after is the angle. So I'm going to work out this little angle here. I'm just going to go tan of theta equals opposite over 4 root 3, and I'm just ignoring this negative just because I'm going to just get that angle, then take it away from 180. So it's going to be inverse tan function, and that gives me 30 degrees. Now that 30 degrees is here. So this is 30 degrees, but I'm after, remember, the angle with the positive x-axis. So it's going to be 180 minus 30, which is 150 degrees. And so in polar form, that's going to be a length of 8 and the angle is 150 degrees. Now you might have a question of why don't I just put that negative in there and maybe it will give me the 150 degrees. Well, maybe, but you've got to remember that tan is also going to be negative down here, okay, in this one here. So it could give me negative 30 here just as much. So it's better to just sketch it on a diagram, work out where it is, and then just work it out that way. So we're going to leave that there. That is converting between Cartesian and polar form. Now you should have, you should be kind of basically up to speed with what we did last year. There's a bunch of exercises and I need you to work very diligently through them because it is new work in our next lesson and you need to know all of this in order to do the new stuff. Okay, thanks for listening.